Okay, so for this question, we're looking at the freezing point and boiling point of an ethylene glycol solution. Calculate the boiling point and freezing point of a solution containing 381.5 grams of ethylene glycol in 2,921 grams of water. That is the formula for ethylene glycol, and the molar mass is 62.07 grams per mole. Okay, so when solving freezing point and boiling point questions, we need to find molality. So, molality, which is little m, molality equals moles of ethylene over kilograms of our solvent, which is water. So we need to find our moles of ethylene in order to get molality. So if we have 381.5 grams of ethylene, just do your dimensional analysis. We find out that we have 6.15 moles of ethylene glycol. So go ahead and plug this into your molality equation. 6.15 moles over, remember they give us grams of water, which will be 2.921 kilograms of water, which is going to give us our molality of 2.1 little m. Okay, and we need to find both the boiling point and freezing point. So we're going to start with the boiling point, and there's an equation, and it's delta T, which is temperature, boiling point, equals the constant for the boiling point times molality. This KB is going to be given, or you can look at it at a reference table, and it is specific for the type of element that you're looking at, which is water in our case, the solvent. So the constant change for water to increase its boiling point is 0.51, and that's degrees Celsius over molality. We're going to go ahead and times that by our molality. The molalities cancel out and you're left with degrees Celsius. So delta T boiling point equals a change of temperature of 1.071 degrees Celsius. Now remember, this is just the change, delta T, of the boiling point, the original boiling point of water, which is normally 100 degrees. So we're going to add our change, which is 1.071. It's going to increase the boiling point. So our new boiling point, not just the change, is 101.071 degrees Celsius. And that makes sense because remember, anytime you're adding a solute to a pure solvent, you're going to be increasing the boiling point and decreasing the freezing point. Remember that. It's very important. So we're going to do it again for the freezing point. So it's the constant change for the solvent for its freezing point times molality. Water's constant change is 1.86 degrees Celsius per molality. Times it by our molality. The change in temperature for the freezing point equals 3.906 degrees Celsius. Water normally freezes at 0 degrees. So the new freezing point, and remember you're adding a solute to the pure solvent, it's going to decrease the freezing point. So if it's normally 0 degrees and we had a change of 3.9, it's now going to be negative 3.906 degrees Celsius. So those are your two answers, your new boiling point and your new freezing point. I hope that all made sense. Good luck.